Okay, in this video, we're going to talk about section 6-4, dealing with proportional reasoning. And in this video, we're going to recognize ratios and their relationships to rational numbers, solve proportions, and recognize their properties, calculate the constant of proportionality, use scale drawings to solve proportions, also use bar models to solve ratio and proportion problems. Okay. Now, proportional reasoning is going to be very important. It is a concept that is taught in grades K through 8. Proportionality has connections to most, if at all, of the other fundamental middle school topics and provides a context to study these topics. Okay, so let's begin with what a ratio is. All right, a ratio is a comparison of two quantities, and it is denoted as a fraction A over B, and sometimes they write it the fraction like this A with a slash and then B, but it's still A over B. They're both the same. And then they also use a colon in between the A and the B. Sometimes they use the word to, like A to B. Okay. And by the way, that's what that colon represents between that A and the B, A to B. And ratios can be represented in three ways. One could be part to whole, or whole to part, or part to part. Okay. Now let's look at this first example. I'm going to leave out part D. Here we're going to answer the following questions regarding the English alphabet. Okay, and in part A, we want to determine the ratio of vowels to consonants. Ratio of vowels to consonants. Now, in this case here, vowels, there are 5 vowels in the English alphabet. By the way, there are 26 letters in the English alphabet. 5 of them are vowels. The remaining 21 are consonants. So if I want to write the ratio of vowels to consonants, there are 5 vowels, 2, and I can use the colon, 21. Or I can write this as 5 over 21 as a fraction. So that's part A. Part B, I'll do this, the last two on the bottom. What is the ratio of consonants to vowels? Well, vowels to consonants was 5 to 21. So for the ratio of consonants to vowels, that's 21 to 5. Or we can say 21 over 5 as a fraction in simplest form, by the way. And part C, what is the ratio of consonants to letters? Well, there are 21 consonants, and there are 26 letters in the alphabet. So that ratio would be 21 to 26. Okay. Now, if you look at part A, this represents a part-to-part relationship. Vowels to consonants, part to part. In part B, this one is part to part as well, but in part C, this is part to whole. Okay. Now, of course, whole to part would be something like if I look at the numbers in the English alphabet to the number of vowels. That would be 26 to 5. Okay, here's another example of ratios. In part A, the ratio of boys to girls in a class is 3 to 2. What is the ratio of boys to all students in the class? All right, so let's think about this for a moment. Boys to girls, there are 3 boys to 2 girls. So for all students, if I add 3 and 2 together, I will get 5. So all students would be 5. So the ratio of boys to all students, that would be 3 boys to all students, which is 5. So for boys to students, that ratio would be 3 to 5. 3 to 5. Okay. So that's part A. Now part B, if the ratio of boys to girls in a class is M to N, what is the ratio of boys to all students in the class? Okay, so here all students, that's just going to be M plus N. M is the number of boys and N is the number of girls. M plus N. So the ratio of boys to all students in the class, boys to all students, would be this. The number of boys is M. That's going to be 2, M plus N. And in part C, it says here, if 4/9 of the class are girls, what is the ratio of girls to boys? And in this case here, 4/9 of the class are girls. So that means the number of boys will have to be 1 minus 4/9. Okay. Now keep in mind, if you want to write 1 with a denominator of 9, how many ninths are there in 1 whole? Has to be 9. So this will be 9/9 minus 4/9, which will be 5/9. So that means that there are 5 boys to 9 students in that class. So if I want the ratio of girls to boys, okay, that would be 4/9 over the number of boys, which is 5/9. And when we divide fractions, if you recall back in Math for Teachers 2, we take that and multiply by the reciprocal of 5/9, which is 9/5. That should be 4/9, I'm sorry. As this is 4/9 in the numerator, multiplied by the reciprocal of 5/9, which is 9/5. That way the 9s divide out, you'll get 4/5. So the ratio of girls to boys would be 4 to 5. Okay. All right, so that's how we do ratios here. And simplify them as well. All right, now we're going to take this a little bit further with ratios and talk about proportions. It says here, a proportion is a statement that 2 given ratios are equal. It is a statement that 2 given ratios are equal. So in other words, if A, B, C, and D are all real numbers, and B is not equal to 0, and D is not equal to 0, then the proportion A over B equaling to C over D is true if and only if A times D is equal to B times C. In other words, these cross products of A and D is equal to the cross products of B and C. All right, now, there are a couple of approaches with proportions. Here, students in lower grades experience problems that are additive. So like in this problem, we have Allie and Bent type at the same speed. Allie started typing first. When Allie had typed 8 pages, Bent had typed 4 pages. When Bent has typed 10 pages, how many has Allie typed? So here we use the additive approach. And let's set this up as a proportion. Here, Allie has typed 8 pages, and then Ben has typed 4 pages. So let's say Allie, and then Ben typed 8 pages. Allie typed 8 pages. Ben has already typed 4 pages. And when Ben has typed 10 pages, we want to know how many pages did Allie type. So here we're going to use what they call the additive approach with this problem. So here, 4 plus what number gave us 10? Well, has to be 6. So 4 plus 6 is 10. So if we added 6 to the 4 for Allie, we need to add 6 to the 8 pages she's already typed. So 6 plus that 8 would be 14. That would mean that Allie has already typed 14 pages when Ben has typed 10 pages. Okay. And then next is the multiplicative approach, because there are some proportions that can be solved using that approach. Like in this example here, Carl can type 8 pages for every 4 pages that Dan can type. If Dan has typed 12 pages, how many pages has Carl typed? All right, so let's look at Carl and Dan. Carl has typed 8 pages for every 4 pages that Dan has typed. And Dan has already typed 12 pages. So that means we need to find out how many pages that Carl has typed. So we're looking for this number right here. Well, using the multiplicative approach, 4 times what number gives me 12? Must be 3. And that means 8 times 3, I have to multiply the number of pages that Carl has typed by 3. And 8 times 3 would be 24. So by the time Dan has typed 12 pages, Carl has typed 24 pages. Okay. So that's how we can use the multiplicative approach here with this particular problem. All right, on the next page, most proportions are solved by using what they call the cross multiplication method. Let's say we have this example. If there are 3 cars for every 8 students at a high school, how many cars are there for 1,200 students? All right, so let's set up this proportion here. Okay, so here 3 cars, well, cars to students is going to be our ratio. And there are 3 cars for every 8 students. So 3 cars to 8 students. And we want to know how many cars are there for 1,200 students. So students, that 1,200 goes here. And we're trying to find out the number of cars. That will be X. So our proportion that we're going to solve would be this. 3 over 8 is equal to X over 1,200. 3 over 8 is equal to X over 1,200. So that's the proportion that we will solve. And of course, we're going to use the cross multiplication method. So here we're going to do the cross product of these two numbers here. 3 times 1,200. That would be 3,600. That's equal to 8 times the X would be 8X. Okay. So now to solve for X, we're multiplying by we're multiplying by 8, so we need to divide both sides by 8. So that means x is equal to, this is 3,600 divided by 8, which would be 450. So to answer the question, there are 450 cars for 1,200 students. Okay. So that's how we solve that proportion. Okay, now here's some more proportions that we will look at in this example. Let's say I want to solve for x in each of the following proportions here, like in part A. 4 divided by x is equal to 24 divided by 30. Now, of course, you can use the cross multiplication method. You can use the multiplicative approach to solve this problem, because you can think of this. 4 times what number gives me 24? Has to be 6. So that means what number times 6 will give me 30? And that will tell me what x is equal to, which has to be 5, because 5 times 6 is 30. So that missing number will be 5. Now you can do the cross multiplication method by doing this. X times 24, that'd be 24x. That's equal to 4 times 30, which is 120. So 24x is equal to 120. Divide both sides by 24. That would mean x is equal to 5. Now part B, we got x over 5 is equal to negative 6 over 11. Now with this one, I don't think you're going to be able to use the multiplicative approach to solve that problem. So we just have to use the cross multiplication method. So we'll cross multiply the x and the 11, which will be 11x, and that's equal to 5 times negative 6, negative 30. So the 11x is equal to negative 30. Divide both sides by 11. This will be x is equal to negative 30 over 11. Now, if you were to write this as a mixed number, I would divide 11 into negative 30. That would be a negative 2. And then I'll have 8 left over. So it'll be negative 2 and 8/11ths. But with me, you could write it as an improper fraction or a mixed number. If I ask for you to write it as a mixed number, then this would be the correct answer. Okay, part C. 7 over 6 equals 2x over 107. 7 over 6 is equal to 2x over 107. And we want to solve this proportion. All right, in this case, let's do 2x times 6. That's 12x. And that's equal to 7 times 107. That would be 749. So 12x is equal to 749. And then we divide both sides by 12. That would mean x is equal to 749 over 12. And if we divide 749 by 12, the whole number will be 62. And then if I do 62 times 12, subtract 749 from it, I'll have 5 left over. So it'll be 5/12. Okay. Now you could write like an improper fraction or a mixed number. All right, and finally, part D. 1/2 is to 8 as x is to 24. This is similar to what they call an analogy. Okay. First number is to the second number as the third is to the fourth. That can be written as a proportion as 1/2 is to 8. So it'd be 1/2 over the 8, and that's equal to x over 24. X is to 24 will be x over 24. And now we can solve this equation or this proportion. That means x times 8 or 8 times x, that's this cross product. That would be 8x equals 1/2 times 24. Now, 1/2 as a mixed number would be 3 over 2. When you do 2 times 1, which is 1 plus the 1 in the numerator, that'd be 3 over 2 times 24 over 1. And then do some cross cancellation with the 2 and the 24. 2 goes into itself 1 time, 2 goes into 24 12 times. So we got 12 times 3, which is 36 over 1, or 36. So 8x will be equal to 36. And then divide both sides by 8. You'll get x is equal to, I can write this as 36 over 8, and then divide 8 into 36, that would go 4 times with 4 left over. So it'd be 4 and 4/8. But I can reduce 4 and 4/8 by dividing the numerator and the denominator by 4. 4 goes into itself 1 time, and 4 goes into 8 2 times. So end up being 4.5, which is what x is. So sometimes you have to write your answer in simplest form. Okay. All right, example 4 is this. There are approximately 2.5 pounds of muscle for every 5 pounds of body weight of a certain animal. For a 130-pound animal, how much of the weight is muscle? Okay. So our ratio will be muscle to body weight. Muscle to body weight. All right, in this case here, 2 pounds of muscle for every 5 pounds of body weight would be like this, 2 to 5. And then we have a 130-pound animal. So the body weight of that animal is 130 pounds. That has to go here in that space. How much of that weight is muscle? So this is what we're looking for. The muscle. How many pounds of muscle is there for that 130-pound animal? So here's the ratio, 2 over 5, and that's equal to x over 130. And then we just solve this proportion as we normally would. So if I do 5 times x, that's 5x, and then that's equal to 2 times 130 would be 260. So 5x is equal to 260. And then we divide both sides by 5. That would mean x is equal to 260 divided by 5 would be 52. So for a 130-pound animal, 52 pounds is considered to be muscle. 52 pounds is muscle. Okay. So be sure that you are familiar with solving proportions like this using the cross multiplication method. Some cases you might have to use the additive method. Some cases you might have to use the multiplicative method. All right, next we'll look at constant proportionality. And that's this: if the variables x and y are related by the equality y is equal to k over x, or k is equal to y divided by x, then y is proportional to x and k is called the constant of proportionality between y and x. Right? A central idea in proportional reasoning is that the relationship between two quantities is such that the ratio of one quantity to the other remains unchanged as the numerical values of both quantities change. So as x and y changes, that k, which is your constant of proportionality, will remain the same. So like in this example that I have here, if Amber is paid $9 per hour for typing, the table shows how much she earns. And that's this table right here. So this one has two parts. Part A, how much would Amber make for a 50-hour work week? And part B, what is the constant of proportionality? Okay, so let's start with part A. How much would Amber make for a 50-hour work week? All right, so let's see here. The table shows that hours are increasing by 1, as you can see. So the wages has to increase by some constant. And if I look at it, if I compare from 9 to 18, that difference is 9 all the way through. So for every 1 hour that Amber makes, she gets, it's increasing by 9, okay? So here, let's see, the amount that she makes in a 50-hour work week would be this: 50 hours a week multiplied by $9 per hour. So 50 times 9 ends up being $450. So that means for a 50-hour work week, Amber makes $450. That's part A. Now part B, what is the constant of proportionality? Here for every 1 hour, she's making an additional $9 here. So that constant of proportionality, which we call K, is going to be 9. Now, the way you could have came up with that would be this: if you use that y is equal to k times x, let this be x and this be y. So here, if I take that $45, that's going to be the y, is equal to k times $5, where she made $45. Divide both sides by 5, you'll see that k is equal to 9. So that will have to be a constant of proportionality. Okay. All right, here's another example dealing with proportions here. And that's this. David reads 40 pages of a book in 60 minutes. How many pages should he be able to read in 90 minutes if he reads at a constant rate? So we can use that y is equal to k times x, which is that equality that I showed you for the constant of proportionality. So in this case here, he reads 40 pages of a book in 60 minutes. So in this case here, okay, 40 pages in a book for 60 minutes. Okay, so y is going to be 40 pages. K is what we're trying to find. X is the time, which is 60 minutes. So that's going to be the setup for this. 40 is equal to K times 60. So if I divide both sides by 60, that would mean K is equal to, this will be a fraction 40 over 60. But if I reduce that by dividing the numerator and the denominator by 20, this will be 2/3. So our constant of proportionality will be 2/3. Okay. So in 90 minutes, okay. So for 90 minutes, it will be 2/3 times 90. The constant of proportionality is 2/3. X is the time. And Y is going to be the number of pages, by the way. So 2/3 times 90 will be 2/3 times 90 over 1. 3 goes into 90 30 times. So 2 times 30 would be 60. 60 minutes. Oh, I'm sorry, not 60 minutes, 60 pages. Okay, because Y is the number of pages that David reads. So 60 pages is going to be the number of pages that David should read in 90 minutes if he's reading at a constant rate. Okay, so that's how we use the constant of proportionality to work problems like this. All right, next we'll look at the scaling strategy. Okay, here we're going to look at a couple of strategies for solving proportions. One is scaling and the other one is the unit rate. Here, the scaling strategy is another approach to solving proportions. Using the scaling strategy to determine which is the better buy would be something like this. Let's say we have 12 tickets for $15 or 20 tickets for $23, and we want to find out which one is the better buy using the scaling strategy. Now, that scaling strategy is used for solving the problem, and it would involve finding the cost of a common number of tickets. In other words, we're looking for the least common multiple, or the LCM, if you recall. And the least common multiple, by the way, is going to be the smallest multiple that is divisible by the two numbers here. So we're looking for the smallest multiple for both 12 and 20. And in this case, it's going to be 60. There are strategies that for finding the least common multiple. You can use prime factorization. You can list all the factors of 12 and the factors of 20. You're going to see that 60 is the smallest, not the factors, the multiples of 12 and the multiples of 20. You're going to find that 60 is the smallest multiple for 12 and 20. So now, in the first plan, there are 12 tickets that's going to cost $15. So if I multiply 12 times 5, since 12 goes into 65 times, if I multiply 12 times 5, I'll get 60. And then multiply 15 times 5, that would be $75. And then for the second plan, which says 20 tickets for $23, well, 20 goes into 63 times. 3 times 20 is 60. And then 3 times 23 will be 69. Now compare those two, you're going to see that 60 tickets for $69 is cheaper than buying 60 tickets for $75. So plan 2 has to be the better buy. So here we use the scaling strategy to determine which is the better buy. The other is the unit rate strategy. Okay. So when we use the unit rate strategy, it involves finding the cost of one item under each plan and then compare their unit cost. Okay. So now Let's use that same problem, 12 tickets for $15 or 20 tickets for $23. We want to find out which one is going to be the better buy using the unit rate strategy. So in this case here, 12 tickets cost $15. So that means if I take that $15, divide that by 12, that will tell me how much one ticket costs. And that's $1.25. And then in the second plan, 20 tickets for $23. Take $23, divide that by 20, you'll get $1.15. And compare those unit prices. As you can see, $1.15 is cheaper than $1.25. That tells me that the second plan, 20 tickets for $23, is the better buy. All right, now here's an example of finding out which one is the better buy. 3 oranges for $69 or 12 oranges for $3.12. All right, so now what I'm going to do here is I'm going to use the unit strategy approach. Okay, starting with the 3 oranges for 69 cents. I'm going to write 69 cents as 0.69. So if I take the unit price, that's 69 cents, divide that by 3. So 0.69 divided by 3, that would be 23 cents per orange. $0.23 per orange. That's the unit price. And then we got 12 oranges for $3.12. So here we're going to take $3.12, find this unit price by dividing it by 12. So $3.12 divided by 12 is going to be 0.26. So this is 26 cents per orange. So now compare these two and find out which one has the lowest price per orange. And it will be this one. 23 cents per orange is cheaper than 26 cents per orange. So that means the 3 oranges for 69 cents is the better buy. Three oranges for 69 cents is the better buy. All right, next example is this. It says here, Alan, Betty, and Carol invested in a corporation in the ratio of 2 to 3 to 4, respectively. If they divide the profit of $13,500 proportionally to their investment, how much will each receive? Okay, so this is one of those unit prices here, or the unit amount that a person can get in an investment. Okay. So here I'm going to let X equal to what they call the unit rate, because this is done proportionally. And in this case here, Alan and this is done respectively, Alan gets like a ratio of 2 times the unit rate. So this is 2 times X. Betty gets 3 times the unit rate, or 3X. And Carol gets 4 times the unit rate, or 4X. And the profit is $13,500. So we add up the proportion for Alan, Betty, and Carol together. So this will be 2x plus 3x plus 4x. And that equals $13,500. So this is our equation here. Now let's combine like terms here. 2x, 3x, and 4x will give me 9x. So 9x is equal to $13,500. And then to solve for x, we're multiplying by 9. So we need to divide both sides by 9. Because you have to think of what number times 9 gives us 13,500. And that will be 1,500. So the unit rate is 1,500. Now we haven't answered the question yet because it does say how much will each receive. Let's find that out. Alan gets 2 times the unit rate. That's 2x. So that means 2 times 1,500 would be $3,000. So Alan receives $3,000. Betty gets 3 times the unit rate, or 3 times 1,500, which is $4,500. So Betty receives $4,500. And Carol gets 4 times that. So that's 4 times 1,500, which is $6,000. Now, you can check by adding the 3,000, 4,500, and the 6,000. You should end up with $13,500. So that tells you that you have worked that problem out correctly. So Alan receives $3,000, Betty receives $4,500, and Carol receives $6,000. Okay. All right, here's another example of proportions here. When 2 gears are mashed, the revolutions per minute, or RPM, are inversely proportional to the number of teeth, as shown below. In one machine, the RPM of the large gear to the small gear is 5 to 7. The small gear has 275 teeth. In the second machine, the large gear revolves at 500 RPM and has 495 teeth. The small gear revolves at 1100 RPM. Okay. So here, we're going to use that particular proportion to answer this question. And that is, find the number of teeth on the large gear of the first machine. Okay. Now we're given the RPM ratio of the large gear to the small gear as 5 to 7. Large gear to small gear, that's going to be 5 to 7. So I'm going to write that as 5 over 7. And that's equal to, here we're finding the number of teeth on the large gear of the first machine. Well, the number of teeth on the large gear, that's what we're looking for. So that's going to be X. And we're told that the small gear has 275 teeth. So 275 will have to go up here. And that is our proportion. 5 over 7 equals 275 over X. And now we do cross multiplication. 5 times x, that's 5x. That's equal to 7 times 275. 7 times 275. That would be 1,925. So 5x is equal to 1,925. And then if we divide both sides by 5, that would mean x is equal to 385. Okay. So in this case here, there are 385 teeth on the large gear of the first machine. Okay. Now here's the other problem. Let's say I want to find the number of teeth. Find the number of teeth on the small gear of the second machine. Excuse me. Find the number of teeth on the small gear of the second machine. Okay. Well, the RPM of the large gear to the small gear is still going to be 5/7. Number of teeth on the small gear is what we're trying to find for that second machine. So that's going to be x over, let's see, the second machine of the large gear revolves at 500 RPM and has like 495 teeth. Okay. So that's going to be our proportion. And let me see if I did this right here. In the second machine, the large gear revolves at 500 RPM. So I need to correct that. It's not going to be 5/7. Because the RPM of a large gear revolves at 500. And then the small gear revolves at 1100. All right, so that would be the correct ratio, okay? So now I'm ready to solve this proportion. All right, so let's do 1100 times x. That's 1100x equaling to 500 times 495. That's going to be this cross product. That would be 247,500. And then divide both sides by 1100 to solve for x. This will be x is equal to 225. So x is equal to 225. So that's the number of teeth on the small gear of the second machine. All right, and here's some other theorems related to proportions on the next page. And it says here, for any rational numbers a over b and c over d with a not equal to 0 and c not equal to 0, a over b is equal to c over d. Those two ratios are equal if and only if I take the reciprocal of a over b, that would be b over a. And if I take the reciprocal of c over d, it would be d over c. It'd still be equal. Okay. And this other theorem deals with pretty much the same thing. rational numbers A and B, A over B and C over D, where B, C, and D are not zero. A over B will still be equal to C over D if I do this. A divided by C, go this way and write it as this ratio, go this way and write B over D as that ratio. Still going to be equal. Okay, so those are just some theorems that we use in proportions here. Okay, next we'll look at scale drawings. All right, ratio and proportions are used in scale drawings. The scale is the ratio of the size of the drawing to the size of the object. Okay, now what I'm going to pull up here is an example, if I can, dealing with ratios. Okay, this is not going to work for me. Okay, but this is what a scale drawing looks like. Okay. Okay, that's what a scale drawing does look like. It's just a floor plan of the main floor of a house, and it's drawn in the scale of 1 to 300. And let's say we wanted to find the dimensions in meters of that living room. But here, that's what a scale drawing looks like. Okay. Now, in this example I'm going to do here, has something to deal with scale drawings here. And those are just not only in, when you're doing drawings of houses, there's also maps that have scale drawings. Usually maps of cities, they're usually drawn to scale. Like probably 1 inch is equal to, let's say, 2.5 miles in real life. Okay, that's pretty much used in scale drawings. So like in this case here, in this example, let's say on a map, 1/2 inch represents 5 miles. If 2 cities are 18 inches apart on the map, what is the actual distance between them? Okay, so if I set up a proportion, this is how we set this up as a ratio. Each ratio would be for inches to miles. Inches to miles. We know that 1/2 inch represents 5 miles. So the 1/2 goes there, the 5 miles goes here. And we're told the 2 cities are 18 inches apart. So that means that 18 must go in the row for the inches. And we want to find the actual distance between them. That would be X. So now we set up the proportion here. 1/2 is to 5. So 1/2 over 5 equals 18 over X. That would be our proportion. And if we do cross multiplication, 1/2 times X will be 1/2 X. That's equal to 5 times 18, which will be 90. So 1/2 X is equal to 90. And to solve for X, normally you'll divide by 1/2, but the reciprocal of 1/2 would be 2 over 1. So let's multiply both sides by 2. That way these 2's divide out, you'll be left with just X is equal to 2 times 90 is 180. And we have to use the correct units here. It'd be 180 miles. So the distance between the 2 cities is 180 miles. Okay. All right. Another way to solve proportions would be using what they call bar models. So if I use a bar model, that can be used as a method of looking at a proportion. And these are two main types of bar models. One would be the part to whole model and the comparison model. The part to whole model and the comparison model. So I'll show you an example of that. So let's say I had a bar that looks like this. And this part right here, all of this represents the whole. Then you have your part and part. So that's the part to whole model. Okay. And I think there's also the comparison model. Okay. Sometimes they use the comparison model like this one right here. Because in this case, you can compare this part to that part and find out pretty much some type of what number times itself will give you the whole thing. Like in this case, what number times 4 would give you the 56, that would be 14. So each one of these would be 14. And then in this case right here, you find out, 48. What number times 6 to give you 48? Will have to be 8. So each one of those boxes will have to be 8. Okay. So that's how they use comparison models and also the part-to-part model for doing the bar model. Okay. Now, in this last example in the handout, two numbers are in the ratio 3 to 4. And let's say I want to find numbers or find the numbers if their sum is 98. So here I'm going to draw a bar model to represent this. 3 parts to 4 parts. So that's 3. And then here's another bar separated into 4s evenly. Okay. So this represents 3, that represents 4. If you add 3 and 4 together, you'll get 7. And then we want to find those numbers if their sum is 98. Okay, so the sum is 98. And there's a total of 7. Let's divide 7 into 98. That will have to be, has to be 14. So each one of these must be 14 in each of these boxes. Okay. All right. So if I wanted to find the numbers, if their sum is 98, that means that the ratio is 3 to 4. So if I add 14 3 times, that means this represents 42. And this represents 14 4 times, that would be 56. So the two numbers that they're looking for will be 42 and 56. Okay. All right, so that does complete this video or this section on proportional reasoning. And do feel free to email me if you have any questions about any of the problems that are presented in this video or any of the homework in the homework set that will be assigned to you. So do reach out to me. Thanks for listening.